Okay, this video is about log properties, and we have to understand the log properties so that we can use them to help us evaluate functions. So this right now is not solving anything. We're simply learning the properties so that we have the ability later in the next lesson to be able to solve. So there's three properties here, and they're listed. If we have two numbers that are multiplied together, we can separate them by separating with addition. If it's divided, we can separate them with subtraction. And if we have an exponent, we can move it to the front. And these are going to keep being true throughout the whole process. So on the first one, right now, it is log of 6 times 11. So to separate that, that would be log of 6 plus log of 11 because we separate multiplication with addition. Now, before we're done, we have to stop and see, can we write any of these as a power? And if you were in class, I had the students put together this power list. It's a little bit bigger than we've been doing before, just so we can keep remembering what we've got. But no, 6 and 11 don't fit any of those powers. So that means that we're just done, and that is our final answer. Let's try this again on number 2. Now, number 2, these numbers are divided, and our rule says when they're divided, we subtract them. So it's going to be log 2 minus log 5. And again, if we consult our powers list, none of those numbers are on there. So therefore, we know that we can't rewrite them as powers. So we know that we're done. And you'll see why I'm saying that in a second. Okay, now let's try it with variables. Well, it's division. So this is going to be log x, because it's division, it's minus log y to the 6. Now it looks like we're done, but we're not. Any exponents we have, we need to move to the front for it to be finished. So our final answer is going to be log x minus 6 log y. All right, so let's see what happens on number 4. It's division, so now we know we can rewrite it as subtraction. So I have log 25 minus log 2. Now 2 I can't rewrite, but 25, I can rewrite that one. So this is really going to be log 5 squared minus log 2. And again, I'm looking at my powers list. See, 25 is on there as x 5 squared. So I'm going to keep referring to that as we go through here. Now, I'm almost done. I've got to move that 2 out to the front. So our final answer is going to be 2 log 5 minus log 2. All right, on the next one, it's division again. So we're going to subtract to separate them. So we have log 49 minus log 27. When we do this, whatever number's on the top gets written first, and what's on the bottom gets written second. Okay, 49 and 27, we can both rewrite. So I'm going to have log 40, oops, that's not what I mentioned, right? I'm going to have log 7 squared minus log 3 cubed. Again, I'm referring to that power sheet. I have most of them memorized, so I don't need to keep looking at it, but it's good to have it handy and ready to go as you go through here. So to simplify, I need to move the exponents up front. So I have 2 log 7 minus 3 log 3. And that's our final answer. Okay, let's look at number 6. Now, number 6 is different because we have a natural log, and we know natural logs are just log base e. But even though it's natural log, not log, it doesn't change any of the rules. It's still the same thing. So this right here is multiplication. So I'm going to rewrite it as addition. So I have the natural log of x squared plus the natural log of y cubed. But I'm not done until I move the number out front. So I have 2 times the natural log of x plus 3 times the natural log of y, and there's my answer. Okay, number 7, it's division, so I'll separate with subtraction. So the natural log of m to the 3rd minus the natural log of n to the 5th. Move the exponents in front. So I have 3 times the natural log of m minus 5 times the natural log of n. I know, poor choice of variables. All right, now, number 8. Number 8, you probably easily see it's the natural log of 64 minus the natural log of 5. Now 5 I can't rewrite, but 64 I got choices. So I could do 8 squared. I could do 4 cubed, or I could even do 2 to the 6. What you want to pick is you want to pick the option where the base is the smallest. So here this base is 8, here the base is 4, here the base is 2. Where the base is smallest, it's most reduced, is the last option. But 2 to the 6th, it's not on our list of powers. So if you didn't know that one, you may miss it. So let's pretend we do miss it and we don't pick the smallest one, we pick this one instead. It's not going to get us directly to our answer, but I want to show you how it actually does lead to your answer. So if I rewrite natural log of 64 as 4 to the 3rd minus the natural log of 5, then I'm going to move the 3 out front. So it's 3 times the natural log of 4 minus the natural log of 5. But you stop and you're like, oh, whoa, 4 I can rewrite. 4 I can rewrite as 2 squared. So I have the natural log of 2 squared minus the natural log of 5. Move this out front. When I move it out front, I have to multiply it. So 3 times 2 gives me 6 natural log of 2 minus the natural log of 5. Now, you can see if I pick 2 to the 6th, I'm going to get there way more directly. So I'm always going to recommend that you try and find the one with the smallest base. However, if you pick wrong, you don't have to erase all your work. You can keep going. It'll still work. Okay. These look different because the ones up here that we started with were just logs and there was no base. And remember, if there's no base, there's an invisible 10. But these have a base. But even though they have a base, still doesn't change my rules. So on number 9, it's multiplication. So I'm going to separate it with addition. So I have log base 5a squared plus, that's not what I meant, right? Log base 5 of b to the 7th. Notice that this log 5, I don't do anything with it. I just rewrite it just like I had log or natural log earlier. Now it's just log base 5. And then I got to put the 2 or the 7 up front. So I have 2 log base 5 of a plus 7. Oh my gosh, I can't write log base 5 of b. And there's my answer. Okay, number 10, because it's division, I'm going to separate with subtraction. So I have log base 4 of x cubed minus log base 4 of y. Move the exponent out front. So I have 3 log base 4 of x minus log base 4 of y. And we're done. Okay, so everything that we did up to this point, I gave you problems like the left, and you had to expand it on the right. Now I'm going to give you the expanded version, and you got to go backwards. So let's take a look. The rules are not changing. We're just moving in the opposite direction. Okay, this first one, because it's subtraction, that means that we're going to rewrite it as division, and whichever goes first is listed on top. So this is going to be log of 3 over 8, parentheses optional. So you could write this as well, same thing. Now, once you get that, you need to see, can I simplify that any? Does 3 over 8 reduce? Nope. So I'm done. It's over. Okay, this one, because it's multiplication or because it's addition, then I'm going to rewrite it with multiplication. So I'm going to have log of 6 times 5. 6 times 5, we can definitely simplify. That's going to be log of 30. There's our answer. Okay, number 3. Number 3, we have numbers in front. And if you remember, numbers in front are exponents. And that was always the last step on the first problems. So now it's going to be the first step on these problems. So I've got to move this exponent. So now I have log 3 cubed minus log 4 squared. Because it's minus, I need to combine it as subtraction, or excuse me, of division. So I have log 3 cubed over 4 squared. I can simplify that, and for these you should. So log 3 cubed is log 27. 4 squared is 16. Okay, over here again, exponents are going to be the first step on these since they're the last step on the other. But now we have natural log instead of log, same thing. So I have the natural log of 2 cubed minus the natural log of 5 cubed. Well, on these, subtraction, I can combine it as division. So I'm going to have 2 cubed over 5 cubed, which is going to give me the natural log of 8 over 125. All right, number 5, again, same thing. Got to move the exponent first. So I have the natural log of x minus the natural log of y to the 4th. Because it's subtraction, I got to rewrite division. Whatever is first goes on top. So I have the natural log of x over y to the 4th. Okay, now we've got a base, but remember it doesn't change anything. I'm just going to keep writing the log 3 here instead of writing the natural log or the log. Same thing. Okay, so move the exponent. So this gives me log base 3 of x to the 6th plus log base 3 of y to the 3rd. Because this is addition, when I combine it, it'll combine as multiplication. But notice this log 3, I'm not altering that any. So now my final answer is going to be log base 3, x to the 6th, y to the 3rd. Okay, number 7. I could rewrite. I got to move the exponents first. So I have log base 5 of x minus log base 5 of w cubed. Now I've got to write it as a division problem because we started a subtraction. Whatever's first has got to go on top. So I have log base 5 of x over w cubed. All right, now 8 looks weird, but we're not going to stress about it because we know the rules. First things first, we're going to move our exponents. Oh, that one doesn't have exponents to move. Okay, so we move the exponents and we get log base 4 m to the 4th plus log base 4 n to the 3rd. We don't care what that base is, but as long as the base is the same for the whole problem, we can combine them. The bases were different, we cannot combine them. Okay, it's like adding like terms. So we got log base 4 of p. Okay, now we want to smash them together. Well, the addition means I need to multiply the m and the n, but the minus means I got to divide by p. So when I rewrite it, I'm going to have log base 4 m to the 4th n cubed all over p. And that's it.